Good day everyone, I am May and B. Sebastian from BS Ed Math 3A. Today, I will discuss the draw diagram method. It says that the draw diagram method can be very helpful in visualizing and obtaining solutions to problems. Often, this method is a first step toward seeing more efficient strategies. To add, a draw diagram method is a figure usually consisting of a line drawing made to accompany and illustrate a geometrical theorem, mathematical demonstration, and etc. Mathematical diagrams can support students to represent a situation and assist in finding a solution to a problem. Teachers can scaffold students' use of a diagram to solve a problem by asking, "Can we draw a diagram?" Why do we need a draw diagram method, or why do we use draw diagram method? Drawing a diagram or a picture is a strategy to help you solve many different problems. The first thing that you have to do when approaching a problem is to read and understand the problem and how to solve it. The second reporter will discuss on what are the steps to draw a diagram.
Good day to each and everyone. I am Siti Jane D. Bansuan from BS Ed Math 3A. So today I am going to report the steps of the draw a diagram. First, let's make a problem solving for us to do the steps. So this is the sample problem. A snail is at the bottom of a 10-meter well. Each day, it crawls up 3 meters, but at night, it slips down 2 meters. How many days will it take the snail to get out of the well? After we gave a solving problem, let's now do the step on how to draw a diagram. So, step 1 is understanding the problem. For us to understand the problem, let's make a question. Number 1 is, what is the snail doing? The snail doing is crawls up to get out of the well. Number 2, how deep is the well? How does the depth compare to the height of this room? So, the well is 10 meter deep. After we answer the questions, that means we already understand the solving problems. Let's now proceed to the step 2, planning the solution. Let's draw a well which is divided into 10 equal parts. Each part represents 1 meter. So let's assume that the bar here is the well and the arrow is the snail. So in one day, the snail crawls up to 3 meters and at night it slips down 2 meters. So the next day, the snail starts in 2, then it crawls up to 4. So at night, bababa ulit siya ng 2 meters. The next day, aakyat siya ulit sa 5. And so on and so forth. So the drawing shows that after 2 days, the snail reaches a height of 4 meters. So let's now proceed to the step 3, solve, do it stage. So let's assume that the arrow and the bar is the well and the snail. So number 1, how far up the well is the snail in 3 days, 4 days, and 5 days? So in 3 days, the snail crawls up to 5 meters. In 4 days, the snail crawls up to 6 meters. In 5 days, the snail crawls up to 7 meters. So every time the snail crawls up, it also added 1 meter each day. Number 2, has the snail get out after 3 days, 4 days, 5 days? So, nasagot na natin yung question number 1. So, ang sagot is, the snail didn't get out after 3, 4, and 5 days. So, let's proceed to question number 3. Continue the drawing to answer the question. So, since we already finished the diagram, the answer is, the snail get out after 8 days. So that would be all. Thank you for watching and keep safe.
Hello everyone. Good day and Assalamualaikum warahmatullahi wabarakatuh. I am Mr. Saidali P. Gantawali and today I am going to explain the process or steps in a draw a diagram method and how does it work. So, why draw a diagram method, or what is the advantage of a draw a diagram method? So the draw a diagram method or draw a picture strategy is a problem-solving technique in which students or solvers make a visual representation of the problem. So mathematical diagrams can support students to or solvers to represent a situation and assist in finding a solution to a problem. So let me show you some problems and its solution using the draw a diagram method. So sample problem. A snail is at the bottom of a 10-meter well. Each day, it crawls at 3 meters, but at night, it slips down 2 meters. How many days it will take, or will it take the snail to get out of the well? So step 1, understanding the problem. So here we have to understand the problem and identify the hints that we can use to solve the problem. So what is the snail doing? So a snail crawls up 3 meters each day, but at night it slips down 2 meters. How deep is well? Or how deep is the well? How does the depth compare to the height of this room? So the well is 10 meters. So step 2, planning the solution. So let's draw a well which is divided into 10 equal parts, and each part represents 1 meter. So the drawing shows that after 2 days, the snail reaches a height of 4 meters. So step 3, solve. Do it stage. So, how far up the well is the snail in 3 days? So, in 3 days, the snail is on reaches 5 meters. How about 4 days? In 4 days, the snail reaches 6 meters. And how about 5 days? On 5 days, the snail is in 7 meters. So, has the snail get out after 3 days, 4 days, 5 days? So of course, it can't, or the snail cannot get out after the said days. So continue the drawing to answer the question. So let's continue. On the 6th day, we have 8 meters. On the 7th day, we have 9 meters, and on the 8th day we have 10 meters. So therefore it will take 8 days for the snail to get out of the well. So more problems for you to better understand how does draw a diagram method works. So number 1, a ball rebounds 1/2 of the height from which it is dropped. Assume the ball is dropped 42 meters from a leaning tower and keeps on bounding. How far will the ball have traveled up and down when it strikes the ground for the 5th time? So, step 1, understanding the problem. What happens to the ball? So, a ball rebounds 1/2 of the height from which it is a drop. So, what is the initial drop of the ball? So, we have 42 meters. What we are going to find? So, we have to find how far will the ball have traveled up and down when it strikes the ground for the 5th time. So, step 2, planning the solution. Let's draw a diagram. So, the first initial drop is 42 meters. Then, on the second drop, we have 21 meters, which is half of 42 meters. Then, on the third drop, we have 10.5 meters, which is a half of 21 meters. Then, on that fourth drop, we have 5.25 meters, which is a half of 10.5 meters. Then, on the fifth drop, we have 2.625 meters, which is a half of 5.25 meters. So, the drawing shows that the ball rebounds one half of the height from which it dropped. So, step 3, solve. So, in the first drop, we have 42 meters. Yes. Then, on the second drop, we have 2 times 21 meters is equal to 42 meters. On the third drop, we have 2 times 10.5 meters is equal to 21 meters. On the fourth drop, we have 2 times 5.25 meters is equal to 10.5 meters. On the fifth drop, 2 times 2.625 meters is equal to 5.25 meters. So, the question is, why 2? Or why it is always the factor of 2? It is because up and down, which means double. Okay, so to solve the problem, let us find the sum of the meters that we have in each drops. So 42 plus 42 meters plus 21 meters plus 10.5 meters plus 5.25 meters is equal to 10.75 meters. So, answer 10.75 meters. So, number 2 problem. Some girls are standing in a circular arrangement. They are evenly spaced and numbered in order. The 7th girl is directly opposite the 17th girl. How many girls are in the arrangement? So step 1, understanding the problem. What is the girls doing? So, girls are standing in a circular arrangement. How many girls are in the arrangement? So that is what we are going to find. So step 2, planning the solution. So let's draw a circle with a lines in a line with 7 and 17 opposite to each number, each other. So the diagram shows that some girls represented by numbers are standing in a circular arrangement. They are evenly spaced and numbered in order. The 7th girl is directly opposite the 17th girl. So, step 3, we have solve. So, right half of the circle, we have 9 girls. On the left half of the circle, we have 9 girls. Since it is symmetric, then 9 plus 9 is equal to 18 girls are in the arrangement. So, therefore, if some girls are standing in a circular arrangement and they are evenly spaced and numbered in order, and the 7th girl is directly opposite the 17th girl, then there are 18 girls are in the arrangement. So the answer is 18 girls. So, third problem, one painter can paint a wall in 10 minutes. Another painter can paint it in 6 minutes. So, same work. About how long will it take both painters working together to do the job? So, step 1, understanding the problem. What is the job rate of painter number 1? So, the painter number 1 can paint 10 minutes for a wall. Then, what is the job rate of painter number 2? So, the painter number 2 can paint one wall in 6 minutes. So, step 2, planning the solution. So, let's draw a diagram. First, painter, we have to draw a wall which is divided into 10 equal parts. Then, second painter, we have a wall divided into 6 equal parts. So working together, we have this. So the diagram shows that 1/6 of 1/6 of the wall can be painted by by the second painter, and 1/10 of the wall can paint by second painter, which is the numerator is the wall, and the denominator is the minutes, so, or the time. So this shows, or this serves as the job rate of each painter, which is 1/6 and 1/10. So which the yellow part is the part of the wall that gets done in 1 minute. So step 3 solved. So working together, the two painters can paint 1/6 plus 1/10 is equal to 4/15 of the wall in 1 minute. So since they paint 4/15 of the wall in 1 minute, then 1 divided by 4/15, which is their job rate, then it is equal to 15/4. So therefore, it will take them 15/4 minutes, or 3 minutes and 45 seconds to finish the whole wall. So the answer is 3 minutes and 45 seconds. So that's all. Thank you.